हेलो डियर स्टूडेंट, आज हम डिस्कस करेंगे लैप्लास ट्रांसफॉर्मेशन। सो लैप्लास ट्रांसफॉर्मेशन में पहले हम डिस्कस करेंगे कि कुछ स्टैंडर्ड फंक्शंस उसको कैसे डिफाइन करते हैं। तो लैप्लास ट्रांसफॉर्मेशन एक बेसिक डेफिनेशंस थ्रू हम स्टार्ट करेंगे। सो कोई भी अगर हमें फंक्शन गिवन है, जैसे कि लेट एफ ऑफ टी is given functions of t variable where t is greater than or equals to 0, then we can say the Laplace transformation जैसे कि Laplace denoted by L of f of t and which is equals to integration. It is defined from 0 to infinity e raised to power minus st into f of t dt. Okay, and it is whatever the Laplace transformation, it is suppose denoted by capital F of s. If it is exist, then we can define the Laplace transformation. So there are some conditions. What are that sufficient conditions? Sufficient conditions for existence of Laplace transformation. So number one, a condition है that will be exist the Laplace transformation. F of t is piecewise continuous for t is greater than or equals to 0. And another one conditions, mod of f of t is less than or equals to n into e raised to power some gamma of t, where this capital M and gamma constants. Okay, so this is the basic definition for the existence of Laplace transformations. Okay, remember these definitions. In case of any kind of the questions will be asked on the definitions. Okay, so some factors and some conditions are there for the existence of Laplace transformation. We must know that. Okay, so remember these words. Okay, and these conditions. What this M and gamma are the constants. Okay, so standard functions of Laplace transformation. So जैसे कि in case we require the Laplace transformation of any kind of the constant number, then we must know that the Laplace transformation of 1. Okay, so how we can define this Laplace transformation equals to 1 by s. Okay, so if we need to prove this, then we must know that solution by definition of Laplace transformation. So what is the Laplace transformation? It is a Laplace of f of t which is equals to integration 0 to infinity e raised to power of minus st f of t dt. So अगर हम ये टर्म्स इसके साथ कंपेयर करेंगे और लिख देंगे उसको, so f of 1 इसका मतलब f of t का वैल्यू 1, तो यहाँ पे आएगा 1, तो यह कुछ इस तरह से 0 टू इन्फिनिटी e रेज टू पावर ऑफ माइनस एस टी, अगर ये 1 रहेगा तो एज इट इज e रेज टू इंटू डी टी. अब इसका इंटीग्रेशन सॉल्व करेंगे और इसको देखेंगे किस तरह से हमें आंसर मिलता है. तो e रेज टू पावर माइनस एस टी का इंटीग्रेशन e रेज टू पावर माइनस एस टी डिवाइडेड बाय माइनस एस, एंड लिमिट दिया है इंटीग्रेशन को, दैट इज 0 टू इन्फिनिटी. ओके, अपर लिमिट एंड लोअर लिमिट अगर पुट करते हैं तो हमारे पास कुछ इस तरह से आएगा e रेज टू पावर माइनस इन्फिनिटी माइनस e raised to power 0 and denominator में minus s. Remember here we are using the with respect to t integration, so whenever t we put infinity and lower limit 0. So finally, so 0 minus 1 divided by minus s, it means that 1 by yes. So we can say the Laplace transformation of 1 equals to 1 by s. So it implies that what? If we require the Laplace transformation of any number, suppose 5, then we can write in this form that constant we can take outside and remaining term means we can say suppose 1. Now we can apply this Laplace transformation of 1. So it will be a 5 divided by 1 by s means 5 by s. Okay. So any kind of the number, it will be a positive, it should be a positive. Then Laplace transformation of suppose 10, then directly we can use the Laplace transformation of 10. It is what? 10 by s. 10 by s. So in this way we can find the Laplace transformation of constant number. Okay. So then another one, standard functions that we consider as a standard form or example. Okay. So let us see e raised to power suppose a t, and we require the Laplace transformation. Okay. So with the help of this, then we can find the Laplace transformation of e raised to power 4t, e raised to power Laplace transformation of minus 4t or any other numbers, okay, which will be positive negative. Let's see what happens if it is e raised to power 80. Then again the solution by using again definition. So we must use the definition f of t equals to integration 0 to infinity e raised to power minus st f of t and then dt. Okay, we are applying for the e raised to power. If we compare this quantity with the definition, then Laplace of e raised to power at means f of t equals to e raised to 1, 0 to infinity e raised to power minus of st, and the value of f of t will be e raised to power at. Just rewrite this quantity 0 to infinity e raised to power. So base here it is same, then we can take a power combined. Okay, so what will be here? We can take t as a common and rewrite this power means in this form, suppose a minus s into t. Okay, then we can apply easily the integration of exponential term. So it is e raised to power a minus s into t divided by a minus s, and the limits are 0 to infinity. So when I put the upper limit in place of t, then it will be e raised to power infinity minus e raised to power 0 divided by a minus s denominator at. It means that minus 1 upon a minus s. So if I multiply denominator and numerator by minus, then it will be a plus, then s minus so it is, we can consider the Laplace transformation of e raised to power 8. So similarly we can define the Laplace transformation of suppose e raised to power minus of 80. No doubt with the same calculations we can define it and it will be the answer s plus a. Okay, so let us see the first one, Laplace transformation of e raised to power 4t. For particular example, Laplace transformation of e raised to power 4t, then we can here see the positive power, then it is 1 upon s minus, in place of a it is 4, so it is simply 1 divided by s minus 4. Here we can apply. Okay, and the second one, that is the Laplace transformation of e raised to power minus of 4t. Okay, so obviously it will be s plus 4. So this is one of the basic level examples, but we can apply this property or these examples in the higher level of the example. So I hope ये समझ में आया होगा. कुछ भी अगर आपको माइंड में क्वेश्चन है, you can ask in the comment section. Thank you for